We're going to talk about solubility equilibrium now, where back in chapter 11 we learned about solubility rules and how things can be aqueous or soluble, or insoluble or whatever. And so this is just kind of going along with that. It's all over there on those tables. That's all I got right now. Those 3 tables right now is what I got. So although we generalize and say that these compounds are insoluble when they don't dissolve, they can actually dissolve a little bit, and so that's why they say that they're slightly soluble. Back in chapter 11, if you looked at those notes, it would say that for you. So to compare the solubility, we would have a salt, whatever that is, breaking down into its ions. Okay, the A and the B are the ions. And then we can come up with a solubility product constant. So K is our constant, right? And then SP stands for solubility product, where we take the ions raised to the coefficient power, and then we can solve for them. So the KSP will be given to you, and then you solve for the concentrations. Okay? The smaller the value of the KSP, the lower the solubility of the compound. So with this table is in your notes, just like all the other stuff. If you have to have it, I'm going to give it to you. Okay? So you don't have to worry about memorizing this stuff. So we're going to do example 5 together, and then I'm going to pass out the worksheet, and we're going to do one of those on there, because this one is easy because it's just 1 and 1, but then if you have a 2 in there or something, that's going to mess things up. Okay? So, well, it makes it a little bit more difficult. What's the concentration of lead ions and chromate ions in a saturated solution of lead 2 chromate at 25 degrees Celsius? And I give you the KSP. So, the first thing we have to know is how to write lead 2 chromate. What's the symbol for lead? Plumbum, PB. And if it's a Roman numeral 2, what does that tell you? Has a positive 2 charge. Okay? And does anybody have their handy-dandy periodic table on the back where it tells you all the polyatomic ions? And can you tell me what chromate is? Make sure you have that for your test on Wednesday. Mrs. Pratt's not going to let you leave. What is it? -2? Okay. So CrO4, -2. So to write lead 2 chromate, it's just going to be PbCrO4, right? Then we're going to show how it breaks down into its ions. So we're just going to write these 2 added together. So it's going to be Pb plus 2 aqueous plus CrO4 minus 2 aqueous. Okay? When we write the KSP expression, I didn't say this before, but we don't include the solid side. We just include the aqueous parts because the solids, just like in the lab, do not change the concentration. Okay? So the KSP is going to be the products multiplied by each other. It's just like when we did the K expressions from last week. So products over reactants. Okay? So it's going to be the concentration of the Pb ion. But since this was evened out, we didn't have to balance it. So it just has a coefficient of 1, so it's raised to the first power. And then the chromate, there's also one of those, so we raise that to the first power as well. Okay? Now to solve, we want to know the concentration of the ions. So we want to know what the Pb is, and we want to know what the CrO4 is. So in order to do that, we're going to plug in KSP in its spot. And then on the other side, wherever there's a concentration, we're just going to plug in an X. Okay? And since it's a 1-to-1 ratio, because they're coefficients of 1, it's just going to be X times X. Okay? Or X squared when you reduce it down. So 1.8 times 10⁻14 is equal to X squared. So how do we get X by itself? Take the square root. Yep. Of both sides. So what is the square root of that? You have to, if you're using my calculator, you have to type in the number first and then hit the square root button. What did you get? 4.14. Check that. It does. You smell like you're on the beach. That's all. What'd you get? If you got like 0.000 something something, did you get that? 424 is what you guys are getting? 1.34 is correct. It's 1.34 times 10 to the negative 7 if you put it in scientific notation, so you don't have to write out all those zeros. Remember, if it's a decimal, you just put a negative sign on your exponent. Significant figures, we need 2. So it's going to be 1.3 times 10 to the negative 7. And since X stands for the concentrations, we need to have a unit for concentration. So what's that going to be? What did we use last week? Molar, M. So that's our answer. Okay, so on these you need to put M for your unit on molarity, molars. Okay, with this is the easy way because X is equal to these two things because we substituted X in. On the worksheet, it's not going to be as simple as that. So we're going to do